All right, so here we're going to look at this question, and the question is, how much electricity is required to liberate 1 mole of hydrogen gas during electrolysis? How much electricity is required to liberate 1 mole of hydrogen gas during electrolysis? So option A, we're given 48,250 coulomb. Option B, we're given 95,500 coulomb. Option C, we're given 193,000 coulomb. And option D, we're given 386,000 coulomb. Again, the question is how much electricity is required to liberate 1 mole of hydrogen gas during electrolysis? So it's very important that you should know that hydrogen gas is an example of a diatomic element. And as a diatomic element, two atoms, all right, two atoms will be equal to 1 mole or 1 molecule of the gas. All right, so the first thing I would want to do here is to first of all write out a balanced equation for the deposition of this hydrogen gas from hydrogen ion during electrolysis. So hydrogen ion, hydrogen belongs to group 1 of the periodic table, so it's a monovalent atom. All right, it's a monovalent ion, so it's going to have a charge of +1, just positive. So it will have to accept 1 electron of electricity to be able to what? Liberate hydrogen atom. So this is hydrogen atom. All right, 1 mole of hydrogen, like I said, hydrogen is an example of a diatomic element. All right, you don't find a single hydrogen existing alone. It's a diatomic element. So 1 mole of or 1 molecule of hydrogen contains 2 what? Atoms of hydrogen. So this is hydrogen gas. All right, H2. Why? Because it is a diatomic element. So we would have to need 2 hydrogen ions, all right, to accept 2 electrons of electricity in order to give us 1 mole of what? Hydrogen gas. So this is 1 mole of hydrogen gas, all right. So from this equation, we have that 2 electrons of electricity, 2 electrons of electricity is required to liberate 1 mole of hydrogen gas. 1 mole of hydrogen gas. All right. So in other words, 1 mole of hydrogen gas would require what? 2 electrons of what? Of electricity. So these 2 electrons of electricity is equal to what? 2 Faraday of electricity. So it's equal to what? 2 Faraday of electricity. And note that 1 Faraday is equal to what? 96,500 what? Coulomb. This is the value for 1 Faraday. Then 2 Faraday will be equal to what? 2 Faraday will be equal to 2 times 96,500 Coulomb. All right. So 2 times 96,500 will be equal to 193,000 Coulomb. So that will be equal to 193,000 what? Coulomb. This is our answer. All right. Again, the question is, how much electricity is required to liberate 1 mole of hydrogen gas during electrolysis? So 1 mole, from this equation, we have that 1 mole or 2 electrons of electricity will liberate 1 mole of hydrogen gas. So in other words, 1 mole of hydrogen gas will be liberated by 2 electrons of electricity, which is equal to 2 Faraday of electricity. And 1 Faraday is equal to, the value for 1 Faraday is equal to 96,500 Coulomb. So 2 Faraday will be equal to what? 2 times 96,500 Coulomb, and that will give us 193,000 Coulomb. All right, so the correct answer to this question is option C, 193,000 Coulomb. All right, it's a very simple and a direct question. It's very important that you should know that hydrogen gas is an example of a diatomic element. All right, so you can only find hydrogen as H2, hydrogen molecule as H2. All right, and note this balanced equation is very important.